I'm going to do a video solution for the written homework assignment, and I just selected one of the questions, and this is the question with regard to the words in the English language. So let's take a look at this. If I look at this question, if I just skim through it, it says that according to some website, some data, it's saying that 60.98% of words in the English language contain the letter E. So that's giving me some good information. We read that information, and the question says we're not sure if we believe it. So we want to test out a hypothesis. We want to test out whether or not that claim that 60.98% of all the words in the English language contain the letter E. So the way we would test that out is that we take a sample. We're going to do a statistical analysis, and we take a sample. We decide we use our math textbook, and we take a sample of 20 words, and then we're going to identify of the 20 words how many contain the letter E. So I'm going to, on my clipboard, take a word, and then I'm going to say, does it have an E? Yes or no? Okay, yes or no. That's what I would write on my clipboard. So the first question says, write in your own words the research question. This actually needs to be written as a question, not a statement. We're asking and we're forming a research question. When we're looking at a research question, we want to make sure that we include the parameter of interest and the population of interest in our question. So in this case, I want to know, is the proportion of all words in the English language that contain an E, is it really 60.98% that was claimed, or is it something else? So we usually have two parts to that. We say, is it equal to the claim that's made, or is it something different? Alternatively, is it something different? The next question is asking us the variable in this scenario. The variable is sort of what the heading is here. Okay, if I look at word one, what do I write down here? Does the word have an E, yes or no? So the variable in this scenario is whether or not the word has an E, yes or no. The thing that varies from word to word is the variable. So now we're going to collect a sample. If I open up my math textbook and I want to just look at one page, and this question said that you were to tell me which page that you picked your words from. And to take a sample, remember we want the sample to represent best we can the population. So we would try to pick random words, as random as we can. Some people just cut and paste whole sentences. That's not taking a sample, a representative sample from the data. Maybe you would just blindfold yourself and try to pick different words across the page. Okay, so I just have down here, I just said 11 out of the 20 words that I picked had the letter E. This is P hat. We know that because we're dealing with categorical data. Okay, the variable is a category, yes or no. We're talking about categorical data, meaning we're talking about a parameter of pi, and we're talking about a statistic of P hat. So in this case, my P hat is the number of words that had an E out of the total of the 20 words. In this case, I said 11 out of 20, which I can write as a decimal, 0.55, which is 55%. So now I want to describe the population of interest. Well, when I'm talking about the population, I'm talking about all the things that I'm interested in. Remember, when I take my sample, I just sample some of the things, but the population is all the things. Remember, I'm interested in what percentage or proportion of words in all the English language. So the population of interest is all the words in the English language. I never include here anything about the parameter I'm interested in. I just talk about all the things that I'm interested in. And then if I want to describe the parameter of interest, well, parameters always go with populations, always go with populations. And I know that the symbol that I want, I already know is going to be pi because it's categorical data. So again, I want you to restate these as complete sentences. When we're dealing in statistics, we typically have written reports, we conduct experiments, and it's very important that we're very precise in our language and not ambiguous about how we're conducting our experiment or our statistical analysis. The parameter of interest in this case is the proportion, okay? I want to say, if it was quantitative, I would say the mean or average, but I'm talking about proportions or percentages of all words in the English language that have a letter E, and that symbol is pi. So in order to test our sample and draw some conclusions, we will generate a simulated distribution. And when we generate a simulated distribution, we use a set of assumptions. First of all, we assume that the claim or the parameter is true. In this case, my claim was that 60.98% of all the words, or pi, the proportion, is equal to 60.98. When I put this in my applet, I'm always going to put this in as a decimal, 0.6098. Then I'm going to make each dot in the distribution have the same sample size as the sample that I actually observed. 20 is n. And then I'm going to repeat it. I want to create a lot of dots. I want to create a lot of p hats. In this case, I'm going to create 1,000 p hats. The more times I repeat it, the closer the simulation approaches a normal distribution. And why do I do that? Because then I want to compare my actual observed statistic to that distribution. This is my observed statistic, not my simulated statistic. I'm going to create a bunch of statistics up here through the applet, and then I'm going to compare the one that I actually observed through my experiment. So let me pull up Rossmann-Chance here, and I'll show you how we enter the information here. When I pull up the one proportion applet, it always starts off with showing probability of heads. I'm always going to put my pi in here, 0.6098. And when I hit enter, you can see that it changes the heading here to show that that's a pi or a proportion. My next input is the sample size, n. Again, when it says describe the process, these are all the assumptions that I'm telling the computer to use to generate the distribution. I know that I want 20 here because that's my n value. And then this number of samples is how many times do I repeat it? 1,000 times. I'm actually going to turn off this animation, and I hide my spinners here. They just add clutter. All right. And because I have a proportion of success, I'm going to click proportion of success down here. And now I'm going to draw my samples. So they're really, what I created here are 1,000 dots or 1,000 p hats, assuming that the true parameter is 0.6098. I'm never going to round this number. I'm going to put in unless the problem tells me to. So this is what it would or could look like, assuming that 60.98% of the words in the English language actually have E's in them. What I do here is I enter in my observed statistic, 0.55. And I'm going to put count in there. I also want to click this summary statistics. This is going to then tell me what the mean of my distribution is here that I created. The simulated distribution is 0.611. It's pretty close to 0.6098, and it should be because that was the assumption I used. The more samples I add, the closer this mean gets to actually be equal to 0.6098. And then it tells me the standard deviation as well of this sample, 0.109. We'll come back to that in a second. So then it says if we use the simulated distribution and the two standard deviation rule to find the cutoffs for what's usual and unusual, then what would those cutoff values be? Show your work. Some people did not show their work here. All right, so what I'm going to do is I'm just going to take a quick snapshot here and I'm going to pull it into my presentation. All right. Oops. So the two standard deviation rule says that if I take my mean, 0.611, and I add two standard deviations, that gives me the upper cutoff. And if I take my mean, 0.611, minus two standard deviations, it gives me my lower cutoff. So in this case, I would take 0.611 plus my standard deviation is 0.109 plus 0.109. That's going to give me my upper cutoff. And I'm just going to do that real quick. 0.611 plus 0.109 plus 0.109 gives me 0.829. 0.829. And then my lower cutoff would be 0.611 minus 0.109 minus 0.109. That's two standard deviations. And that gives me 0.393. So what that says is that so long as, okay, and this is approaching a normal distribution, this tells me that anything in between 0.393 and 0.828 is considered usual. And then anything that's above it or below it would be unusual. So I'm going to take a look at my observed statistic, 0.55, is in here, right? So it's within the usual, right? It's in between 0.393 and 0.829. So we would say that this is usual. So let's come down here. So if it's in this usual area, then we would say that it's believable or plausible that 60.9% of the words contain the letter E. And to show this and defend and explain this, we would say because our observed p hat, which is equal to 0.55, is between 0.393 and 0.829, it's considered usual, meaning that it is plausible that 60.98% of the words in the English language contain the letter E.